Good. Thank you very much for coming. Nice to see that there's still so much interest. Konnichiwa, genki desu ka, ii desu ka?
It's on.
Daijoubu desu ka? Ah, sugoi ne. So, happy to see that Commodore 64 is still a topic or still raises some interest. It definitely does for me. Few words about me. In daily work, I'm a Linux kernel hacker, specialized on embedded systems and doing lots of low-level stuff, and I still prefer limited machines. If people come to me and saying, hey, have you heard about this new ARM quad-core with super-duper GPU graphics power? So that's not what amazes me. So, yeah, well. But with limited machines getting something done, that's what raises my interest, and this is because I grew up like this. I'm hacking the Commodore 64 since 1988. I just realized that's 23 years. 23 is always a nice number. And I've been mainly interested in the demo scene, which was back then very, very hype and laid the foundations to the demo scene we know today, even if it's PC or whatever. And yeah, it is a passion. I don't know if Zen is the right word, so I put a question mark behind it, but searching enlightenment via excessive practice is not an understatement. I really did this a lot, and I learned a lot. And it is part of my history, so it made me who I am today. And I'm not so active like I used to be, but I have still a lot of interest, and I have still a lot of ideas left. What I'm going to show, the demo, is of course not my personal work. That would be too much. It is a group effort. I mainly work with some close friends of mine, also located in Germany, and a group of people which are in Hungary. And I really have to thank them because it's always a great collaboration. I think we collaborate now for more than 7 years, and it's always great fun working together. And I really have to thank them a lot. Also, I want to mention that I want this talk to be seen as a case study. This is one example, I think an interesting example, but it doesn't mean that this demo is the best C64 demo of all times. I think it's a good one, though. We're not the absolute gods of C64 coding, and there are other people doing great stuff at the moment. This is one case study, and it's not even meant to be a glorification of the C64, although it is a very cool machine. But there are other platforms, and I'm usually easily bored by platform wars. So if you have another 8-bit machine and have a great demo, I'll be the first one to appreciate that. I also understand if people get bored by C64 demos, because I get bored with PC demos. So that's kind of fair then, I guess. Some short facts about the Commodore 64. I don't want to talk too much about it. I think Michael has doing the last times great overviews of the Commodore 64. Just for those, or to fresh up, we have a 652-based CPU which has less than 1 megahertz, 3 registers, 56 opcodes, although we use some extra ones. I'll be talking about that. Few addressing modes. We have no multiplication on assembly level, of course no sine, cosine, so it's more like adding, shifting, stuff like that. 64 kilobytes of RAM. People are always amazed how less that is. I still think it's quite a lot. Forget about the ROM. Yeah, first thing you usually do is switch it off to get all the RAM. The machine has various graphics modes. The one which is used in this demo is mostly 160 by 200 by 16 with the limitations you see there. But we have movable object called sprites. We can, C64 is very famous for it. We can place it and we will use it. Yeah, sound, the famous SID. This is quite a mighty synthesizer, I think, because of the modulation and filter options. We have to load in data, so we have to take care of the disk drive. 170 kilobytes per side, so you can turn the disk. Remember that part, turn disks. Sadly, it's connected by a serial interface, which requires even handshaking. So it's very, very slow, especially if you use what is supplied from the beginning. And one other gimmick which is used in demos usually are the internal timers, which can be chained to each other. They're a bit underestimated, but they're quite powerful, and I like them a lot. The design choices about this specific demo, it's a bit special in that case that we had the music in the beginning. Usually you have a concept, and then you have a musician who tries to follow the concept with some music. But this time it was around, there was a music already present, and we had a few effects were already done, and Oswald, who's really, really, really good at designing demos, had the idea, this tune has so much potential for a demo, and came up with a script. And given by this music, we wanted high pace, really effect, 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 not showing too long. What's the last point here is really meant right in your face. Here you have it. With other demos you notice, okay, there's some filling material, either to build up some tension or because they have loaded new data or for whatever reasons, and we wanted to avoid this or empty screens as much as possible, which was quite a lot of work. The next demo we decided on a slow pace, and that was so relaxed to do, but it's missing the kick, I think. So, with that bit of talk, I want to show the demo now, so everybody has seen it at least once. You see the current work state, because when we released it, it was a 90% version, then we put out 91%. What you now see is like maybe 93, although it's 5 years ago. But actually, we tried to finish it for this talk, but we couldn't make it. Although we have internally makes some good steps to finish it really somewhere. No promises though. So let's see. Let's hope everything works now. It's an emulator though. Forgive me about that, but the C64 has just such a strange pulse signal, it usually confuses beamers, and if you want to go safe, you use emulators. So please turn me down and the volume up. Yeah, thank you very much. Glad you liked it. Before we talk some further, I need to define some terminology which is established in the C64 community. These names are there for ages, although they're sometimes weird. I will probably talk or mention the term speed code a lot, which is basically unrolled loops. Maybe you have heard that before. You just skip loops because iterating over loops costs some extra cycles and you want to save that. I took here some very primitive, simple example. Load a value from a sign table indexed with an index register, add another value of that table with another register, and store that as a pixel to whatever graphics mode you just have. And instead of doing this in a loop, you just put the offset here again, sign table, and then the pixel again. Do this 1,000 times and you have a simple plasma. Okay, you can do a bit more nifty things to make the plasma look better, but it's as simple as that, and that is why I generally don't like these plasma wavy thingies, because they are just too boring, I think. Speed code, unrolled loops. Sometimes I might mention illegal opcodes. Those are in fact just undocumented opcodes. Back in the days, that sounded perhaps not cool enough, so they were illegal. This is just from the fact that not all opcodes were wired to some useful or planned features, so they had some open and didn't bother to knob that out. So they do strange things, and people have learned to understand those strange things and make use of it. So we have actually more opcodes than those that were documented. And if you really go for the ultimate thing, you should use those which are useful. And in fact, I own one world record, which is only possible because of these illegal opcodes. There's no way you could have done that without them, but that's too much detail, just believe me. Sometimes I might talk or slip through the term raster time, just interpret this as cycles. It's based on that because you know the raster is building up the screen, and if you take some time or burn some cycles, the raster moves. So sometimes it's called raster time. To get a glimpse on what happens, things we do, I called it, self-modifying code is a central way of doing demos. I don't think there's any decent demo without self-modifying code, and it doesn't matter if you modify the arguments of an opcode or the opcode itself. It's all the same. Code is data, data is code. You do with it what you want. Sometimes tables are mixed patterns of code and data and whatnot, so we make extensive use of that. One other example is we abuse a stack. What you here see in the first line is I want to get a lot of information from a table, so I could just get the first value here indexed, increase the index, so that will cost me 6 cycles. If I just get a value from the stack, pull accumulator, I get it from the stack, it just costs 4 cycles, and the stack counter will automatically move, so I can just do the next pull, and I will get the same value for 4 cycles without taking care of incrementing something, and it leaves we just have 3 registers, it leaves 1 free. So there are routines which completely use the stack as a table of whatever. The problem is when you have interrupts, the processor will use the stack to store data on it. So you have to copy that somewhere else and later put it back. And in the end, this is some kind of sliding window technique. So you have the stack as you want it. Tell that to your computer science professor. He will be very happy about that. He would also like this one. Okay. On the C64, it's pretty important sometimes that you do really certain things at a certain time. 1 cycle off and it won't work. So first you have to eliminate some jitter, so you know when you get something stable, so you know when you are where. And this is usually done by timers, using timers. And let's now just assume the DC06, I like talking in hex values. I would never do this when doing kernel code, but when I do C64, I would never give that a define. That's DC06, that's a timer. And let's assume if you read that timer, you know how much jitter you have. And one thing you could do, you read the timer, feed that value into a delay loop, and once you run through the delay loop, you're set. You have everything stable, you know where we are. There's one thing I don't like about this approach, there's a delay loop. I mean, we have just 20,000 cycles per frame, and I hate delaying very much. And there's one way to get rid of it. DC04 is another timer, which you can imagine is rightly in front of that one. And we write some values to it. You could now think, okay, it's counting 4C, what's that? That's 76. Okay, it's probably counting 76 cycles for whatever reason. But later we see this is setting up the interrupt vector. Low byte 04, high byte DC. Hey, we've seen that, that's DC04. It's directly jumping into the I/O register space. It's accessing code here in the first timer register. And now I can tell you 4C is the opcode for jump. I don't care about 76, the timer is not running, it's constant memory. So this is the opcode for jump. This is the low byte of the opcode, so it's 0, it could be anything, wherever I place the routines. Now what is the high byte of the opcode? It's DC06. That's the timer who gives us the jitter. So it changes with every cycle, it changes, the jump instruction changes, and when we jump to it at exactly defined times, we will jump to a very, very specific jitter routine, so we can optimize it for that special occasion. That will terribly fragment memory, but it's really fast. And this is used in doing one graphics mode where you have 100 extra interrupts per frame, and it wouldn't be possible without such techniques. I love such things. Okay. There are, so to say, two sets of effects on the Commodore 64. I call them, the first one, table-based effect. And those have lots of tables and lots of speed code. And the magic is in the tables and the speed code generators. If you look at the speed code itself, you probably will not figure out anything because it's just shuffling data around and you see no pattern. These are more mathematically based effects. For example, if you saw the tunnel there or stuff like that. And yeah, those are for people who like 3D effects or whatever, mathematically based. They're easy in that part that if they're too slow, well, they just look slow and you can try to make them faster. You can use some chunky modes to get them faster. Then you have resolutions like 80 by 50 or whatever. If you use dithering, you can hide that. And most people also call them new school effects, where new school means like 1995 and ongoing. Remember, next year the Commodore 64 will turn out 30. This is quite a lot. And those effects are usually really, you know that, in frames per second. 50 would be good, that would be the maximum, or 1 frame. 25, it depends on the effect, you can do that, but some people do 10. That's not very enjoyable for the audience, I think, but some people are very brave in that regard. The other type of effects are VIC, this is the graphics chip or register-based effects. They might use speed code, not so much, and pretty simple tables, and the magic is the actual code. So if you look at the code, you see a lot of registers written, and if you know the registers, you can really get the idea of what is going on there. They mostly run in interrupt context to make this stable thing more easy. Must be cycle exact, like I mentioned. And this is different from the others. If your code is too slow, the effect is impossible. Because you need to set up a certain amount of registers in a certain time. And if you fail to do that, you won't create the or program the chips as you want. And you will just get a black screen or whatever. So this is what the old school effect were famous for, cycle counting. Okay, I have to do this at that time, and I have to do that at that time. Okay, I could do this. Oh, no, I need to do that as well, but it won't fit. And then you start doing some magic, and if you're good, it fits. It's a totally different style of effects. And the nice thing about the combination from the Hungarian guys and me, or our group, is we can do both. And we can combine that. We're not the only ones who can do that, but that has a lot of potential. If you maybe remember, at the beginning there was a bump mapper, looks like a torch was shining onto something. The bump mapper itself is a new school effect. It needs a lot of tables, not lots of speed code, but it moves. And the moving is an old school effect because all the CPU time is done to do the actual bump mapping. We need a fast way to scroll. And then you can use old school effects, because then you can start poking in registers and confuse the poor VIC chip so much that it gets totally confused and shifts the picture around. And this combination between new and old school, there's lots of potential still left, I think. I don't want to spend too much time with this one, just to give you an idea what's used. These days it's mainly really only cross-development. I started in 1996 with cross-development. Back then I was laughed at and killing the true feeling and stuff like that. But it's status quo today, especially when it comes to coding. But you should always pay attention to test everything you do on the real machine, especially if you do graphics, if you do sound. Otherwise you might have strange surprises. With code it's a bit easier. Yeah. Of course, we're using the internet, they being in Hungary, or one is in England, and me being here. Interesting thing is that the whole demo was compiled using my old Pentium laptop running DOS, but it was working fine since '96, and I never had a reason to change. And I think it still did a pretty good job. But other than that, every developer has the freedom to use what he wants. So there's Visual Basic, Java, and whatnot involved. That's the basic memory layout I tried to impose on the other people, because I could impose because I was responsible for the linking. So I could say I'm aiming for that, and the lowest things are given by the hardware architecture. The 0 page is special because you can access this memory very fast. This is the stack. And then I decided, okay, we need a loader to get data from the disk. It needs some buffers, and we have a depacker, which is relocatable, so I can move it around if I want. Some temporary stuff. The music, which needs to be in memory present all the time, and this is here you can do what you want with the parts. And now let's take the recursive mapper, which is also in the beginning, as an example. So far so good. It uses the 0 page, a bit of a stack for variables. Here are some temporary tables, and here's the init code, table speed codes. It's new school effect, so there's lots of speed code. We're lucky, we have 500 bytes left. That can be quite a lot. So you think it's all fine, but then, oh no, there's this special table without which the effect can't work. Sadly, that is terribly fragmented, but I'm tempted to show you why it won't work. Okay, yeah, I'll be brave. And you be too. The nice thing with the way I do it that I can not only compile the demo as a whole, but also parts separately, which makes testing a lot easier. No, music off is okay, we don't need that. Okay, this is the part. And now go to the monitor. Can you read that? Can you read that in the back? Yeah? Good. Okay, that's just shows some code. Speed code. It shuffles memory around, gets it from some table, puts it somewhere. This is indirection, so it's more or less a pointer. Some 99 blah, I don't know. So try to make a pattern out of that. Let's look at the pointers. Oh, okay, that was not good. Ooh. Yeah, the font is too large, but if I make it smaller, you won't see much. Okay. Will you believe me, it points to roughly the same memory. If we go to that memory, we see another speed code, which shuffles memory around again. This is in fact the screen memory, so here the screen gets updated. And you see here, it gets, again, values from some tables. And the tables, always, the high byte and the low byte, are always in the range 0 to 0f. And this is one of the key tricks of that effect, because it's recursive. It's important that the index to the table can be used as an immediate value or as an address here. So this value can be just, again, it's a speed code with lots of self-modification. We modify the speed code, so we need that. We have to directly put this value here, or let's say here and here, or we need it in a register to work with it further. Scary, huh? And all I wanted to... No, I don't want to close. Okay, well, if you're happy that way. This is what I wanted to mention, why those tables have to be exactly there. And you can't move them, so you have to work around it. So the key thing to remember is you can make great plans, but demo part coders will always come across and think of something else. You have to deal with it. There's no way around it. So there is a table destroying my loader code, so I have to back it up somewhere before. So I have to do a lot of relocation, and this is really, really ugly, dirty work, but there's no way around it. Talking about loading, I don't want to meet the Commodore engineers who designed that. Or actually, they had good plans for that, and it was mainly the management who spoiled that, because they wanted some awkward backwards compatibility. So the engineers couldn't use all the hardware features which could have made loading fast. It is really awfully slow. And you cannot use the routines Commodore delivered at all. So demos have their own way to improve the situation. And one way to do this is, well, usually you have a clock and a data line. So you have 1-bit transfer. And we use the clock line as a data line too. So we have a 2-bit transfer. That means we have to use the attention line, which is just for basic signaling, more or less like clock or handshaking line, which is a bit dirty, but works reasonably well. The drawback is that you can have only one drive attached to your Commodore 64. If you have 2 drives attached, they will be totally confused, but with 1 drive it works fine. But you have to design it all for yourself, you need custom code in the drive, because Commodore drives are intelligent. They have their own CPU, they have their own memory. And so you write code for that too, to make a proper loading system. There are advanced demos who use the drive as a coprocessor. So while the Commodore 64 is cleaning the bitmap or whatever, doing some drawing, the floppy drive is actually rotating some points, and thus the rotated points are sent back, or stuff like that. Back in the days, it was very cool to do everything on your own, so people did their own loaders, but as you can imagine, it's pretty hard. So a lot of them crashed and did not work reliably. As a result, we have just a few these days, and these are commonly used. One of them is our Dreamload, which has a special feature. You can run it from a hard disk, which is available, or even from the MMC cartridge. That used to be a feature which was cool, but it got a bit outdated. People have other hardware, and you don't really need to support the hard disk anymore. So that's a bit of a pity, because we could put quite some effort into it. But you have, as a result, you have to take care of loading all yourself, to design the protocol, get it stable. And keep in mind that your drive is not the only drive in the world. It involves mechanics. So if you tune your loader for your drive, it will perfectly crash on the next one, because the mechanic is a bit worse and it can't come up with what you programmed. A rule of thumb, you want good compression to minimize loading. If you can avoid loading, do so. So what can you do to do packing, crunching, compressing, whatever, how you name it? There are millions of compressors out there. Everyone has his favorite, and people like to do their own. Most are LZ based. I used the best packer around, which is called Exomizer, which is really good. And it's astounding how long you can, a gigahertz or 2 gigahertz PC can take to pack 40 kilobytes. It's not like minutes or hours, but a few seconds. And it was really designed to achieve the best packing results, which is nice in many ways, but the drawback is that sometimes the depacking is too slow. So we pimped it a little bit with some parameters, and that worked out pretty well. Oh, and I rewrote the depacker, so it's larger, of course. There has to be a trade-off, but it's faster. But if you want to have a decent packing system, I don't think you can take something off the shelf. You have to invest a bit of time to that one as well. But that worked quite good. The other rule of thumb is you know your data best. Use your a priori knowledge. You know the symmetries of your tables. You know where delta packing might be sufficient. And try to not rely on a generic compression algorithm. If you know something which could be helpful, use that. This is a lot of work, but if you want to save loading and want to keep a high pace, do that. And then we needed to put it all together, because you can imagine if you work on a demo on a part, you work only on that part, you want to get it going, and once it's done, if it does roughly what you want, you consider yourself done. And then you want to throw 7 or 8 of them together. That won't work that way. You have to, well, I won't read it all. This is really, really the dirt work. Everybody I know hates it. It's usually not regarded in the scene. It's God-given, and still it's the #1 reason why demos fail, come not into existence, stop at 64 or 90% versions, doing this right, removing all the glitches, doing some transitions. But there's no way around it. You have to go through it to to get the proper flow. And here's where you have the trickiest part to keep all in 64 kilobytes of memory. I have this part running, I want the next part loading, where can I do it? Oh, I can shut off maybe half of the part sometimes and then load that already. And this is tricky and totally different from demo to demo. I don't think you can use a generic framework on that, not with C64 demo effects. As I tried to show you with the memory layout before, this is too special. There will be always one special case where all your framework won't work, so it's mostly handwork. There's only, in this demo, there's 3 global things more to say. It's load from disk, depack, and call the music. And everything else has to be handled individually. And even after being done at 90%, I don't see more to generalize. Synchronization. It's usually a good idea to do that with music. People like that, and me included. If things are timed to music, if music switches and you have an effect, something switches on the screen as well. Because music is played once per frame, once the raster beam runs through, you just use a simple counter. There's no magic. You have to keep in mind with syncing that loading drives are mechanics, so loading times can be different from the system you use yourself, so always use some tolerance. Most coders have a really, really bad floppy drive. They call it, I don't know, killer drive or bad drive or whatever. The worst drive they could find, and they test their demos on them. And once it passes on that bad drive, you can consider yourself done. And yeah, another nice thing, music players do use instruments internally. I don't know, do a bit of pulse, do a bit of noise, and you have a drum, something like this. And they have numbers, and you can peek into the music player, find out which memory location contains the instrument number, and okay, then you find out if instrument 6 is a drum, and then you can check in your code, is currently a drum used, then, I don't know, light up the effect or change the color scheme or whatever. This is also often a nice way to spice up your demo. Okay, now I'd like to show the demo again with some minor comments. I think we can leave the music off, so because I will be interrupting anyway. Just to point out some more specials. Now I gladly killed my terminal. Let's see if I get tips. One thing, I don't know if you heard that before. Here, this is the so-called border, and this is the visible area. I mention this because soon there will be an old-school effect, which is crossing the borders. It used to be a main effect back in the days, but these days you can just add it somewhere to give a bit of, oh, that was nice feeling, or that was, oh, they took care. Nice detail. Here we went through the border with the graph. It's nothing breathtaking anymore, but it's some extra effort, which is nice to put once in a while. Okay, here, as I mentioned, the main effect is a new school effect, but we are able now to add an old school effect to get this moving, and I don't think this has been copied so far. let's get away. One thing I'd like to mention here is that we also decided to entertain the audience a bit with additional graphics here on the left side. That used to be, I had to change my way of thinking because I always wanted to put all the energy into the effect itself, but Oswald rightfully convinced me that we need to put some elements onto it, because displaying this graphics, because it takes 10 to 12% of CPU time. We need to use sprites for that, and those need to be multiplexed. So here are 4. We just have 8 sprites. So usually they would be ending here. So we have to reuse them, which requires additional code, displaying sprites, not all that. But I think he's right. 10% might not be too noticeable, and it gives a little extra feeling to the demo part. This one is special because it's what we call a loader part. It's I think 20% of the time is used to load the next part into memory. Actually, it was just meant, well, we need something to do, or let's do a plasma. I said they're pretty easy, but Oswald tried hard to make a high-resolution one, and he succeeded in that. We made a very good move with moving the girl into the middle, because you have a full-screen-like impression, right? Although just roughly one third of the screen are calculated by the plasma. And so what was intended to be a loader part is now I think if most people on the net, if they want to put up a screenshot of our demo, they use that, although it's just it started to be a loader part. Pretty amazing. But the sad thing is, we know how fast it actually could run if you don't have the loading in the background. And so that makes us a little bit sad. Luckily, you don't know. So you can enjoy it as you see it here. The rubber cube. Yeah, originally, think cubes are easy, you just draw lines, but now the lines try to shape, hey, that needs to be lots of mathematics involved. The key thing here is you draw the cube into buffers, so you have a set of buffers, and pick from older buffers. What you actually display is a mixture of current and older buffers. So I wouldn't call that cheating, but I don't know if some people on PC would do, but it gives a very good rubber cube. Yeah. Well, the Hungarian guys are really good at math. And although this is Oswald's part, and he's very good at this speed code table thingy, and I know there are some lookup tables involved using shadow, and I rewrote the part because his speed code generator was taking like, I don't know, 3.5 seconds, and that was too long, so I optimized the generator. I'm quite sure he wouldn't recognize it anymore, so it just took 1.5 seconds, but what the part actually does, I still haven't figured out. Okay, this is a 7-color twister. This is, so to say, an old school effect, because on every line here I set up an amount of registers to display the line itself. And I do this 192 times, and then I'm done. Which is pretty nice, because it leaves all the upper and lower border again for loading. And while this part is displayed, we load the next 2 parts and keep them in memory for later. It's also technically not quite interesting, because I don't think any internal counter of the graphics chip is the way as it was intended. So it's totally confused. There's just one problem with the part. Have you noticed? It's fucking ugly. We ran out of time to add a proper object. Meanwhile, thanks Joe, I have a proper object, this is generated from some, I don't know. And now we got a hand-drawn object, and the movement is very, very bad. I mean, it looks like stretching, not really like twisting. It should be a twister. But the final version will definitely improve on that, because this was one of the main blockers for the final version. That is what we call coder colors, you know. Every graphician would run away crying with seeing that colors, but well, I'm a coder for a reason. The graphics are all hand-pixeled, by the way. I think they had a photograph as a reference, but it was not wired, as we say. It was really hand-pixeled, and I think given the constraints, they did a really, really good job. Yeah, and this, I don't know. It's a free-directional tunnel. The final version you will be able to control it with your joystick to see its real time. The creator, Bubis, has a PhD in math. I think you need that. No idea. I fell off my chair when I saw this for the first time. Think about it, we have still 985 kilohertz, and we do a free rotating tunnel there. Well, beats me. Also, this is a filler. We have to get rid of that in the final version. That's just too boring. I don't like the graphics too much either. Yeah, and then we have the tunnel. We have to admit that the calculation of the movement, that's all pre-calculated, but the filling and the filling is done in real time. And this is another part of which will be greatly improved in the final version. Yeah, that was that. Oh, one thing I changed, it now reloads itself, so once you started it, you either stop it or will run endlessly. Yeah. I think this was it from my side. I hope you could find something interesting in that for you. I hope it wasn't boring or could give you an idea. And of course, if you have still questions, I'm eager to hear them.
We have 10 minutes for questions, so if there are any questions, please raise your hand so that an audio angel can come to you. Yeah, okay.
All right. Where were you in the 80s? We needed you. No, actually, why wasn't this possible in the 80s? I mean, I've seen a lot of Commodore 64 and nothing goes... I mean, just the last scene was a bit like the game Way Out. But everything else was just totally amazing and beyond what was being done in the 80s. So what makes the difference?
Evolution. I can't probably say more than that because, of course, with those new school effects, they were influenced by PC demos sometimes. They had more computing power, so they could try free directional tunnels. And once they had this done, C64 coders tried, okay, let's try that on our machine. So this would be one answer to that, and it takes time to really understand the machine. This is what troubles me in real life. You know, I work for Linux for new CPUs, and once we have the basic set of drivers and everything in the main line, the processor is discontinued, and you start working on the next one. That's somehow stupid. And a lot of things which are abused here are more or less flaws in the chips, but it takes time to find out that there are flaws, and then it takes time to find out what you can do with these flaws. And we're still, it got rare, but there are still once in a while somebody comes and shows something on the Commodore 64 which has not seen before, after 30 years. It takes time.
Any more questions?
Yes. Maybe I want to connect to this question. Is it possible that emulators got an impact on developing demos on the 64 because of easing the development cycles? Is it possible?
I would extend this to cross-development in general. My first system I had was a cross-development system where the assembler editors and everything was on the PC. And I transferred the object code to the C64 via cables. That was already a big help. Using emulators is another help because you can stop the machine at any point in time without any side effects. There are very good freezer cartridges, so you can stop the real machine, but they tend to have side effects. So it makes it a bit easier, yes.
Okay, I have another question. I really understand that you have to use self-modifying code to show such demos. Is it possible to reuse code, or do you write every demo from scratch? Can self-modifying code be reused?
Yeah, because you can reuse the generator. Every code has, even the self-modified code, has an initial state. And you can reuse that. But reusing in this term, at least from my point of view, it means if you want to use something from older demos, it's copy-paste and hack on it until it fits to the current demo. I don't have any kind of library or so, but that tends to not work for my case. I'm not sure about all the others, but I would think it's rare.
Okay, thank you.
There's one question on the ISC.
Yeah, there are actually two. Finkel is asking what your favorite C64 demo is.
That changes over time. At the moment, I like very much Andropolis from Boost Design, which has a very astonishing 3D part, which is real time. And I like Insomnia from 64 pretty much. And there was one Fairlight demo I just forgot. Doesn't matter.
And Delroth is asking, did you find or fix any bug in the emulator while working on this demo?
I didn't fix any bugs, but emulators had to be fixed for that demo. Yeah. That happened because I'm the guy who really likes to do the register-based effects and try out new things. I think there are quite some, but a few improvements resulting from my work. Yeah, that's always fun. Gives you a good feeling.
Okay, one more question.
I have two questions. You have a macro assembler on C64. Don't you use macros for speed coding, for example?
The problem, yeah, you can do that, but the problem is that speed code, it has a pattern, but for example, the addresses you use change very much. So a generic packer will have lots of problems with that speed code. So that results in large binary blobs you have to load. As I said, you have a priori knowledge. You know how the pattern is, and using these generators, you save a lot of code. It's really like these generators are I don't know, 500 byte, 1 kilobyte or whatever, and the packet code could be 12 kilobytes or 20, so you usually don't do that.
Okay. And on Commodore, you can have a scene manager, because I am from the PC scene and we use scene managers, but I don't think that, I don't know actually if Commodore have enough power for that.
For what?
Scene managers.
No, I don't think so. That's, yeah.
So how do you manage the scenes? It's like
Yeah, we have a script written down more or less, and then we work on that according to that script, sync to the music, and then it's more or less done manually.
oh, well, okay.
There's one more question in the back.
So how does the demo team organize itself? Do you use version control, or do you use ISC, and how do you communicate? And does everyone work on his own part, and in the end someone has to like put it together, or is it, is there cooperation involved?
It depends a bit. Usually we use a lot of email and IRC. So far we did not use a version control system, but for our next demo we will start using one. It's a bit of, Oswald is really a great coder. He lacks a bit in terms of software development methods. So for, was it this demo or the next one? We introduced him to the magic of makefiles. Sorry, Oswald, but that was necessary. So we will next introduce version control systems to him. What else? Working on the parts, sometimes you have an idea and work on that individually, and then in the end show it to people, and then they have comments or not. But sometimes you already have a script, and then you have an empty spot there, and then you collect ideas together, and one starts, and others add to it. So that depends a bit on the situation. It can be that really one coder is responsible for a part, but it can also be a team effort.
Okay.
Or like with the bump mapper, Oswald comes to me and says, okay, I want to do this, and I will do the bump mapper, and I need a routine from you which does the scrolling. And then we define some interface, and we throw it together.
And which version control system are you intending to use?
Once again?
Which version control system are you intending to use in the future?
Subversion, because...
What?
Do you want to explain Git to someone who just learned Makefiles?
But he's got a PhD, right? So...
No, that's it. The PhD was the other one. No,
okay,
I think it's... See, we have Windows, Mac, Linux systems, and I think it's okay to use Subversion as the least common denominator. I will use Git SVN for sure, and I'm happy with it. They will be happy. I don't want to force something on people. I just want to work with them as they want and as they're used to, and most people in that regard are used to Subversion.
Okay, thanks.
Okay, there's one last question here in the audience.
Hi, I'd like to ask another question which is connected to the previous one. How do you organize in the sense, not what tools do you use, but how do you interoperate personally? Do you explain stuff to each other? Do you educate each other? Or is it more like splitting tasks and work individually and put it all together afterwards?
No, we're teaching and we're explaining stuff to the degree the other person wants. So I am more the specialist for these register-based effects, and the other guys are more specialists for the table-based effects, but that does not mean that we don't know shit about the other part. So we do know something, and we do want to improve our knowledge, so we discuss to a certain degree. I did not want to know all the mathematics behind the three-directional tunnel. I'm just happy that it's possible to do on the 64, but to a certain degree, we work as a team and explain stuff to each other. We also discuss ideas. Do you think this is possible? What would it need, and how could it be done? Do some brainstorming together also, yeah.
Okay, I'm sorry, but we are running out of time. So thank you, Ninja, for this wonderful talk.